Welcome back. After learning so many supervised techniques in terms of regression, classifications, and we have learned so many models, this question always comes: uh, how to decide the model which we have right now, is it really good enough? Then there are multiple ways. Here I will explain you in terms of few of the data and few of the statistics point of view. But in a simple English, your model is good enough as long as business accepts this model. Basically, outcome, you are happy, it is meeting your business requirement, that model is good enough. Definitely the scope of improvement will always be there, because 100% will never be achieved, and we have to almost keep on trying that achieve near to the 100%. Now let us know the few of the facts through which you can find it out how to know that your models are good enough. There is a concept called bias versus variance. Then how to identify bias versus variance? Bias versus variance you can identify in a multiple ways. First of all, let us define that. Let's assume this is your classification technique that has identified basically 0 and 1 kind of situation. And if you see, this is a simple line only. And if this is a simple line, and this is the another curve which has little bit basically it's not the simple line, it has a different kind of curves which it try to predict the maximum of at least one class, and there are error is very less. And there is a one perfect scenario almost predicting almost 100% accurate. So these are the three different scenarios. So what are these three different scenario technically called? So if you have this kind of scenario where there is a high error even in the self predict, basically in the trend data itself, that is called bias problem, and this is also known as underfit. Let's go to overfit. Overfit means almost a perfect situation, but it's good, it's there almost, it's very good for the prediction on the trend. But this kind of this kind of model does not do the very good prediction on the test. So definitely it is a high variance problem, and it is also known as overfit. But what is your right way? This is your right way. You are not expecting 100% right, but at the same time not very high error. So let's go into a little bit more detail. If you have a prediction basically in the trend data on a very high error, like very high error. High error means it is not acceptable by business. Basically, it is not expected as per the problem you are trying to solve. Then you are in the problem of high bias, basically underfit. It means you should work to improve the model itself. You may have the one model, multiple model, ensemble of model, whatever, but it is you have to fix the modeling first. The second scenario that in your self predict, basically in the prediction on the trend data, it looks quite good. But on the test data, it fails. Fails means again this 12%, I'm not saying it is high or low. It means definitely it is not meeting your requirement. Plus it is beyond your expected value and so on. So this is the high variance, basically overfit. And if you get a situation where even the trend data error is high, test data is high, it means it is a hopeless situation. It means everything is nothing is correct, you can say. So this is high bias, high variance. To never get into those. Okay. Now, when you have the low bias, basically the trend prediction is quite low, test prediction is quite low. This is the expected situation, and this is your right way that yes, this is the right state you should be in. So you should try to achieve this state almost every time. And it may happen that you can reach to this state after few iterations. It may happen 2 iterations, 5 iterations, 10 iterations, but whenever. But this is the ideal goal. One should try to reach it in every project. Now, when you have the high bias, then how can you solve the problem? Bigger network. Bigger network means basically try to get the more data in terms of the more features, basically column addition, not the row addition. Row addition is there, it's good, but mostly focus on the getting more and more features that might be impacting your output dependent variable. And if you are using any kind of advanced algorithm, try to tune the parameters and train longer. Basically, try to increase a little bit more, have the more number of trees, more depth, and more iteration. Basically, that is what it means. High variance, more data. More data in terms of basically you should have the more data. Mostly here I'm talking about the rows. If you have the column, well, but rows definitely yes. Hyperparameter, yes, this sometimes helps. There's something called regularizations. Regularization, I would like to know that few paper I have read where regularization is increasing the high variance. Few research paper I have read where regulations helps to reduce the high variance. So I will suggest you that regulation, you use it and see in your data how does it helps you. Does it increase the variance or decrease the variance? So depending on your data, you take the call. Because right now I'm seeing I have seen the research paper for both directions. So I cannot say confidently that which one it will do it. But in my case, regulation has reduced the high variance. That is why I put it here. And I will encourage you that you test regulation in your data and see whether it is reducing the variance or reducing or increasing the variance. I hope this bias and variance was useful for you. Thank you. See you in the next video.